Simple definition to start. Family of functions. You may have heard this term before. It's not like a super important one for us in a lot of ways, but if it happened to be used in a question on a test, you wouldn't want to be confused. So family of functions is a set of functions with the same roots, essentially, or the same X-intercepts. So we're going to use the idea of a family of functions as a step towards writing equations of polynomial functions given graphs or given information. We've talked about this before. Talked about this yesterday, I think, or the day before, in a functions class, learning about functions. And what we've done over the last 2 days is looking at the equation of a graph and using it to determine some characteristics of the function. So we talk about graphing functions, but really it's like the nature of the function. So do you remember doing exponential growth in grade 11? Yes? Sort of. Graph looks like this. What's true? Does anybody remember something that's true of exponential growth? It grows really fast, okay? Compared to other things, exponential growth, you've heard that saying, growing exponentially, right? People say that. What does it mean? It means growing fast, okay? Doubling every time at every iteration is fast growth compared to something like a quadratic or even a cubic, okay? So we're comparing, like that's what we care about. In terms of the quadratic growth or quadratic graph, the relationship, we care about what happens over time to a satellite that's falling out of the sky. That would be quadratic growth or decay. Okay? Whereas exponential growth or decay is different. That's what we care about, is that relationship. But the graph is a good way of thinking about how the graph is changing over time or as the x's change or whatever you want to call it. Does that make sense? So that's why graphing is important. That's one of the reasons why graphing is important. So back to what I was saying, we look at the equation of a graph, and sometimes we can get some of the characteristics of the relationship directly from the equation. Does that make sense? And that's useful. Again, back to grade 10, when you look at quadratics, when it's in expanded form or standard form, there's not much going on there. But when you put it in vertex form, you know a lot about the graph. So that's the kind of understanding that we're aiming for polynomial functions as well. So what have we done? We've looked at equations, and we've talked about how to sketch them so we know something looking at the equations. So now we're going the other direction. What if we look at the graph? How do we pull the important information out of the graph in order to write the equation? And then being able to go both directions makes us better at both of those things. Okay? So if you can sketch this, I didn't provide it for you, but I think it's just a sketch, so you just want to make sure that it's opening the right way. It's got, what do we call this? A straight pass through -2, a turning point x-intercept at +1, and a straight pass through at +3, and it gives us the y-intercept. These questions always have to give you a point. Okay? And so what can we do with this graph? Like, how much information does it give us? Does anybody have an idea? Yeah, it is. That's right. So we know what direction it opens. That tells us something about something for the equation, although it turns out that we don't need to worry about that. Yeah, Megan? It should have what? Even degree. Yes, very good. That's right. That's something to think about. What else? Specifically, Can't we get the x-intercepts and their order directly from this? That's what the opposite of what we did yesterday. Yesterday we were given the x-intercepts and their order in the equation, and so we knew what the graph was going to be like around those x-intercepts. So can't I do this? Y equals, so I'm just going to go left to right. This is going to be x plus 2. That means an x-intercept of negative 2. Because if I put negative 2 in for x, it'll be 0. In factored form, all of the factors are multiplied. So if one of them is 0, the whole thing is 0, right? Think about that algebra. Think about y. That's 0. Don't take that for granted either. These are some of the little things. And what's going to be the exponent on that factor? Because every one of these, it'll be 1. Because it's a straight pass-through. Okay? And if you want, we can write these things down. So we could say the x-intercepts, I don't know if I have a ton of room here, but I'll try. X-intercepts are negative 2, positive 1, and 3. And this is a straight pass-through. This is a turning point. This is kind of hard to see because I'm trying to write too small. And this is, again, a straight pass-through. So the positive 1 gives me an x-intercept of x minus 1, so that when I put positive 1 in, it makes that bracket 0, multiplied by everything else makes the whole thing 0. That's what an x-intercept is. But this one had better have an exponent of 2 on it, don't you think? And then finally, x minus 3 is my positive 3x intercept, and again, exponent of 1. What don't we know? Because that's not the right equation, or at least not necessarily. What's missing? What don't we know? Okay. Yep, it should. So negative what? Negative 1? How many people think negative 1 is going to be that graph? Like, how do we know it's not negative 2 or negative 3 or negative 0.004? We really don't. We know it's negative, but we don't know anything else necessarily. So this is what we call a family of functions. I've just put A in front. That's this definition of family of functions, is like you write in the x-intercepts and you stick an A out front. Okay? So when it says family, like write the family of functions, that's what it means to do. Write it with a variable as the leading coefficient. And write the x-intercepts or whatever in this case. And so now, does anybody have an idea of what we can do to find the actual equation? Because we can find the equation. Megan. Well, yes. We're going to make it equal 6, because can't I sub in both sides, right? I can sub in for x and y, and then solve for a. This is something, if you didn't see this or you still don't see it, okay, so let's do this. So at the point, what was it, 0, 6? 0, 6. So y is 6 equals a times 0 plus 2 times 0 minus 1 squared. Don't miss those exponents. That's an easy mistake to make. And now we can solve for a. Folks, this is a skill that you have been doing since elementary school and is something you have to get used to noticing on your own. Okay? What is the point of an equation that relates two or more variables? I can sub in for some of those variables and solve for the others. Okay? In grade 9 and probably even in elementary school, we also do a little bit of rearranging formula. So I may not be able to solve to a number for a formula, but I can still solve for like I could solve for x. I could figure out what x is in relation to y. Do you understand what I mean by that? I could rearrange, or I could solve for a in relation to x and y, or something. Like I could rearrange this formula to solve for something else. X would be hard, but and this is something that like we should just start recognizing. Like everybody in here should start recognizing and looking for, oh, I'm given x and y. This is a physics thing. If you take in science, it's about like what are your givens? You can sub in and solve for whatever's left, right? We can always do that. That's a tool in your tool belt that you should be thinking about no matter what unit you're in. And in fact, in trigonometry, it's big too. We talked about that in Unit 1 in particular, okay? And in every unit coming up, it's going to be the same thing. And in advanced functions, it's a huge deal that we have two sides to the equation. I can sub it on one side, solve for the other, sub it on this side, solve for the other, like go any direction, right? So that's what we've done here. We subbed in, we're going to solve for A. I'm going to take lots of nice steps here, but you could probably streamline this process. Careful, -1 all squared is +1. So I've got 2 times 1 times 3 is 6, so -6, so 6 equals -6A. Divide both sides by -1, and look at that. Jason, you were right. A is -1. Turns out. And we're going to restate the equation because that was the point. Don't stop there. Therefore, y equals negative, bracket x plus 2, x minus 1 squared, x minus 3. Once again, I would encourage you to, if you're doing your homework, even if it doesn't ask you to, you have graphing software up on your computer or your phone or whatever, and plug that in and make sure it looks like the picture. And it should. Unless for some reason the picture has been made strangely. But they should, like it's tough to tell with the scale, but they should look more or less the same when you get the coefficient and you graph them, right? Any questions about that? Okay, let's try another one. So why don't you go ahead and try to write the family of functions. And notice how a lot of people picked up on, I wanted to do one other thing, so stop, don't do that yet. Notice a lot of people picked up on how both arms were pointing down, so the leading coefficient was negative, but we didn't worry about that. We didn't take that into account. We just subbed in, and that worked out itself. So it's great that you knew that, and if I did some math and that worked out to be positive, I'd be like, wait a minute, that can't be right. I've made some kind of mistake. I forgot to square the -1 or something like that, right? That would be a simple mistake somebody might make. So you should check it with your understanding of the graph and of the function, but we don't algebraically, that will work itself out. Does that make sense? I just thought it might be a good idea before we move on to the next question. Let's write out like the end behavior just to practice doing that kind of stuff. It's something that should jump out at you and that you think about. So this one goes from, I'm going to think about the quadrants first. So it comes from quadrant 3 and goes to quadrant 4. And so the end behavior for that is as x goes to -infinity, y, good. Don't make up a different notation for this. It's not negotiable. You've noticed this in prior grades where, like, for domain and range, it seems like, just write it the way that makes sense to me. No. You're not allowed to do that. This is like a formal mathematical thing. This is like learning about capitalize, what kind of words we capitalize when we're writing. It's the same. You don't get to choose that. No, teacher, I'm going to do it a different way than what you do. No, we all do it the same way when you use question marks, that kind of stuff. This is the same thing. It's a notation, but it's very formal. It's very specific. You got to do it right.
Would it matter which end behavior you put first?
No. But start with x. But whether you do x to -infinity or x to +infinity, no. At least not for me. I bet you there's like a university professor somewhere who would mark it wrong if you did it that way. And then, so as x goes to +infinity, y still goes to -infinity because it's pointing down in both cases. So there's your end behavior for that one, right? We already knew the leading coefficient was going to be negative. We can pick out the x-intercepts and the nature of the x-intercepts, what they're like around those x-intercepts. Pass through, straight pass through, turning point, or cubic twist. All right, now let's move on to this one. So now go ahead and try to write family of functions. So what's different? So a lot of people have moved on already, so I'm going to try to catch up here. So I start with y equals a. And what are my x-intercepts? So x, it's one of them's at -3, so x plus 3. One of them is at -1, so x plus 1. And, one of them is at +3, so x minus 3. And then what did I forget? My exponents. So this one's just a 1, so that one I'm good for. This one should be a 2. So I got to stick my 2 in there. And then this one, look at that. It's not a straight pass-through. It's a cubic twist. So 3. So again, x-intercept, if you want to write this down so that you can look back at your notes later, it might not be a bad idea. My x-intercepts are -3, which is a pass-through. -1, which is a turning point, and +3, which is a cubic twist, okay? And then this gives me that. The turning point gives me that. Exponent, make sure we know that we're pointing at the exponents, and the pass-through gives me this, which is like a 1. All right, so, whoops. Now we can, oh, that's not going to work. Now we can put in our value, so at, and this one doesn't give us the y-intercept, but that doesn't matter. Any point will do. Okay, so 132, and so I get 32 equals a, 1 plus 3 to the 1, 1 plus 1 squared, 1 minus 3 cubed. 32 equals a times, so that's just 4. That's 2 squared, and that's -2 cubed. 4 times 4 times -8. So what does that work out to? 128, is that right? And -128, and I divide both sides by 128, and that reduces to, yeah, And what do we have to remember? Therefore, y equals negative 1 over 4x plus 3. And don't forget your exponents here as well. Just little mistakes that people might make. All right. How do we feel about that? Okay, I'm going to let you try this one. Very much the same idea, except instead of in graphical form, it just gives it to us in words. So this is a common way that you might see it. Negative 3, order 2, negative 4, and 2. If it doesn't tell you the order, then the order is 1. Okay? And it gives us a point that it goes through as well.
Mm-hmm.